Hello, algebra students. Mr. Lawrence here, and we're going to do a little catch-all in solving equations and inequalities. I've got 4 problems here. I want you to try them on your own, and then I'm going to work the solutions. Not really anything new here, just kind of catching up on what we've done the past several days. I will get a little frustrated because my mouse, my airliner, is acting strange again. It's got that lag going on. I'm not sure what's up. By the way, it is okay to use a calculator because you got a big number over here. Oh, wait, that's not the right number. Silly, Mr. Lawrence. Let me fix that number. I think it's supposed to be just a plain old 26, if memory serves. All right, but don't use it for the easy stuff. Okay, so if you're still watching at this point, I want you to pause the video and try these 2 problems. I'm going to show you my solutions in just a minute. Okay, we're back. Yes, I hope you didn't miss me too much. And let's see here. We've got 5 minus 2x over 3 equals 1. And of course, the first step is to get rid of this 5, right? We're listening to Saddam in a problem like this. Okay, it's one of our favorite things to do. We're going to undo subtraction and addition, and then undo division and multiplication. You got to be careful with Saddam on some other problems because the subtraction and addition could be tied down by division or multiplication, like if it's in a quantity or something like that. So you got to be careful with it. But in this case, it's okay to do it this way. So my mouse is jumping all over the place. I've got a 2 attached to x, I've got a 3 attached to x. Otherwise, or you could think of that as a 2/3 if you wanted to. But the 5 is attached by addition, right? It's a positive 5, so I'm going to subtract 5 from both sides. And when I do that, my new equation was driving me nuts. I don't think I'm going to be changing colors much this video. Negative 2/3 x, that's going to equal negative 4. Now, you guys are in algebra. You should be able to handle this. Normally you'd say, well, I want to get rid of the 3 and then I'll get rid of the 2, but we can get rid of them both in one shot. Look, let's put it in parentheses, okay? And I would normally multiply by 3 to get rid of the 3, right? In fact, there's a negative there, so I'll multiply by negative 3. But before I do that, oops, there we go, stop and think, how would I get rid of this 2? Well, division, so I'm going to divide by 2. So I'm going to do negative 3 over 2 times negative 2 over 3. And then over here on the 4, I've got to multiply by the same number, the negative 3 over 2. And I'll put the 4 over 1 just to make it a little bit easier to work with. Okay, so when I do it over here, Wonder Woman shows up and cancels out the 3's and the negatives, and she also cancels out the 2's, leaving me just an x. Over here on this side, I'm going to divide the 4 by the 2, Wonder Woman doing her thing there, and then the negatives can cancel. Negative times a negative is a positive. I'm left with 2 times 3. Some of you are forgetting to do that multiplication. You're just like writing down the 3. No, that's 2 times 3, right? And 2 times 3 is 6. Now, of course, we should check our answer. We're going to get 5 minus 2 times 6 over 3. Well, let's see. That's the same as 5 minus 12 over 3, which is 5 minus 4, and that equals 1. And look up here. The equation equals 1. Okay, problem number 2. Now, I don't like those fractions in the problem. I'm going to multiply. I normally would multiply by a 6 to get rid of this fraction, but I would need to multiply by an 8 to get rid of that fraction. So I need to use a number that's going to get rid of both fractions at the same time. Now, some of you just want to multiply them together, and sometimes it's a good strategy and sometimes it's not. I instead am going to count by the larger denominator, because I'm looking for the least common multiple. I'm going to count by 8s, all right? And so I'm going to get, by the way, I'm going to yell stop when I hit a number that 6 goes into. So 8, 16, 24, stop! Sorry, I hope that didn't scare you too much. 24 is my number that I'm going to multiply. Well, good morning, Mr. Dukers. Come on in. My son James just woke up. He slept in a little bit, which is a good thing. He's coming in to watch the video. I don't know, he's half asleep. He may say something. And then again, he may not. All right, so I'm going to multiply all three terms by the 24. I don't know if you realize this, but I'm distributing on the left-hand side. And the reason I have to multiply on the right-hand side is that old seesaw idea. If I do something to one side of the equation, I have to do something to the other. The same something that is. All right, so let's see what Wonder Woman's going to do for us here. Well, the 6 is going to cancel, turn into a 1. And the 24 is going to turn into 4. And 4 times x is going to be a 4x. The 8 is going to cancel with this 24, turn into a 3. 3 times 3x is going to be 9x. And then 24 times 26, some of you probably figured out that I accidentally had written the product there before. It is 624. Again, it's okay if you use a calculator.
Daddy,
all right.
When you shouted...
You're talking into the video right now, just so you know.
When you
Go ahead.
shouted, you made me jump.
Oh, when I shouted, yeah, it made my student. James says that when I yelled stop, he jumped, and tell him you guys do the same thing. All right, so 4x plus 9x is 13x, and then we'll get 624, of course, and then we'll just have a one-step equation, and we'll divide by 13. And I don't have any cool tricks for dividing by 13, other than I think I know what the answer is from before. But let's go ahead and divide 624 by 13, and I'm going to get 48. And there you go. And of course, you can check it. I'll leave that up to you to check. All right, let's scroll down here, and I've got 2 more problems for you to try. We've got number 3 and number 4, so go ahead and pause the video. Oh, by the way, I should be doing solution sets, shouldn't I? I'll tell you, I'll make sure I do solution sets and graphs on numbers 3 and 4. We don't want to just get in the habit of getting them done, per se. All right, if you're still watching this video, here comes my solution. Again, if you haven't tried these problems yet, please pause the video. All right, I'm looking for the least common multiple. How do I know? Well, in the last problem, we multiplied by a number that would get rid of both denominators, right? Okay, now let's take this real slow. This is really easy, but it's not necessarily intuitive, but it follows directly from what we just did. What would you normally multiply by to get rid of this denominator? And I hear some of you shouting out 1, and I disagree. There is not a 1 in the denominator. Some of you are shouting out x, and I disagree. That's not a denominator. That's not in the denominator either. What number is in the denominator? And you're thinking, oh, there's an x and there's a 1. No, there's an x plus 1. So you see, to get rid of the denominator of this fraction, I have to multiply by an x plus 1. A quantity of x plus 1. But getting rid of the denominator in the second fraction, an x plus 1 isn't going to do it for me. It doesn't match 1. Oops, I wrote the wrong number there. Okay, make sure you take a hall pass. Okay, James is whispering that he's going to the bathroom. Sorry, this denominator should be an x plus 2, right? Excuse me. As I was saying, multiplying by an x plus 1 won't get rid of that denominator. What will get rid of that denominator? Oh, multiplying by an x plus 2. A quantity of x plus 2. So you see, I've got to multiply all 3 terms by the quantity of x plus 1 times quantity of x plus 2, like this. Oops, I made one small mistake. No, that's okay. Yeah, you're not going to be able to solve this one. You're not going to have enough information to do it. But I am still going to demonstrate the method of getting those denominators along. Yeah, sorry about that. It just dawned on me that I gave you a problem you probably don't know how to solve. But we'll see what we can do with it. We'll go as far as we can go, and then we'll stop, with the promise that down the road we will be able to do it. Now remember, right now we're focusing on what's going to cancel. Over here on the right hand side, of course, I'm going to do my double distributing. And if you do that correctly, you should get an x squared plus a 3x plus 2. Okay, now on this first fraction here, you see this x plus 1 here? See x plus 1? What's that? You see Wonder Woman? I do too. Wonder Woman! she shows up, and now I have to distribute the 5 to the remaining quantity. So I'll have 5x plus 10. Okay, Sean, did you catch that? I just distributed 5 times x, 5 plus 2. The x plus 1 is divided out. All right, over here on this one, the x plus 2's are going to cancel out. And then I'm going to distribute the 3. So I'm going to get a positive 3x plus 3. All right, I'm going to combine like terms on the left-hand side. It looks like I'll get an 8x plus a 13. And that's going to equal an x squared plus a 3x plus a 2. Okay, I'm going to take this as far as I can. Like I said, you're not going to have enough information to be able to solve it. I'll know how to solve it, but I know something that you don't yet. You know, I'm not saying that to be mean. It's my mistake. I should have worked this one out ahead of time. I would have caught my mistake and given you a better problem. But please, please, please focus on what we did to get rid of the fraction. That's the important part of this problem for right now. So I'm going to get an x squared minus a 5x minus 11. And to solve this one, you would need something called the quadratic formula. Okay? So I can't do the solution set for it, but I'll make sure to do it on this inequality down here. All right, this problem here, it looks a little bit different because you have a quantity being divided by a number. Again, I'm going to get rid of my fraction first. I can't subtract 6 first because there's not really a 6 in the problem. Why not? Because that 6 is being divided by 2. And there's not a 5x in the problem because the 5x is being divided by 2. That 2 is like mucking things up. So if I get rid of that 2, get rid of my fraction, then everything gets a lot simpler. So I'm going to write down 6 minus 5x is less than or equal to 20 because the 2's canceled on the left-hand side. So now I'm going to subtract 6 from both sides. And I'm going to get a negative 5x. And that's going to be less than or equal to 14. Now I'm going to divide by negative 5 on both sides. Sorry, man. So do I. X is going to be greater than or equal to 14 fifths. That'll be what? Negative 2. Oops. Negative 2. Good morning, Nicole. Sorry, I'm having a little trouble here. I'm getting distracted. Let me see here. Make sure you guys close that door. It gets cold in here if you don't. Okay. So I'm going to have negative 2. Just please be patient. I'll be done in a minute, guys. And 4 fifths. Okay, my solution set is going to look like this. X is any real number such that x is greater than or equal to negative 2 and 4 fifths. Got to close my little bracket there. And then, remember that's a negative 2 and 4 fifths. And then to graph that, I'll have a number line. That doesn't look much like a line. My mouse is really behaving strangely. Here we go. There's a number line. I'll put some arrowheads on it here in a second. Yep, arrowheads. My son thinks that's a funny word. I'm not sure why. But there we go. I have to show the number negative 2 and 4 fifths because it's relevant to this problem. I can show a 0 if I want, and I can show, say, maybe a negative 4. Don't need to show anything else. I know all those other numbers are there. Now, do I need an open circle or closed circle at negative 2 and 4 fifths? Well, it's equal to, so I'll do a closed point. And I got to quit calling it a circle. I've been teaching kids too long. It's not a circle, it's a point. It's going to be a closed point. And then remember, to tell which way I'm going to shade, I'm going to find a number that makes this true. Now, don't make this tough. If you're a kid that gets screwed up with negatives or something, just it's a negative number on the right-hand side. Pick a positive. Pick 5. And wouldn't 5 be like way over here somewhere? So that means I've got to shade in the direction of 5. And this mouse is really getting bizarre on me. Let's see here. Let's see. Let's shade this way. No, that's not a point. All right, there we go. So Any number greater than or equal to negative 2 4/5 makes the original inequality true. All right, that's going to be it for this video. Mr. Lawrence signing off. Have a good night, everybody.